Now we move on to electromagnetism, which is creating magnetism from an electric current. If we pass an electric current through this wire, it creates a magnetic field around the wire which will deflect a compass needle. If I increase the current, we get a stronger magnetic field and the compass needle deflects more. If we move further away from the wire, the strength of the magnetic field is less and the compass needle moves back to its normal position. If I swap over the connections to pass the current the other way, then when I switch on the current, the needle deflects the opposite direction, showing that the magnetic field has changed. We can use a plotting compass around the wire to find the shape of the field, and it turns out to be circular. And if I swap over the connections, the shape is the same, but the compass needle points the other way. And just to show there's nothing special about this piece of wire, I put the compass near this bit of wire here, and that deflects the needle as well. So any current throwing through any wire causes a magnetic field. The shape of the field around the wire is circular, like this. And you notice that closer to the wire the field is stronger, so the field lines are closer together. Further away the field lines are a bit further apart because the field is weaker. Now we need to be able to work out which direction to put the arrows on our field lines. This is where we use our special rule, right hand grip rule. So we use our right hand, make a thumb, okay, and my thumb is going to point in the direction of current flow. So from plus round the circuit to minus. So the current in this diagram is flowing downwards. My fingers are then curling back behind the wire. So that's the direction that I put the arrows on my field lines. If the current was reversed, I'd put my thumb going upwards and the field lines would be curling this way, so the arrows would point the other way. So remember, the right hand grip rule. The magnetic field due to a single piece of wire is quite weak. To make a stronger magnetic field, we can wind the wire into a coil called a solenoid. By having all the wire in one space like this, we effectively combine the magnetic field from all parts of the wire. So how can we make the field stronger? Well, we can increase the current, or we can increase the number of turns on the solenoid, but it's still not really very strong. To really increase the strength of the magnetic field, we add an iron core to the solenoid, which turns it into an electromagnet. So just like for a bar magnet, we can use a plotting compass to investigate the shape of the magnetic field due to a solenoid. And it turns out that the shape is very similar to that of a bar magnet outside the coil. Inside the coil, the field lines go straight through, nice and evenly spaced. So we have a uniform field inside the coil. Outside the coil, it's shaped just like a bar magnet. Again, we need to be able to find the direction of the field line arrows, and we use our right hand rule again, but in a slightly different way. If you look at the diagram, the current is flowing around the coil that way. So what I do is I take my right hand and I curl my fingers in the same direction the current is curling. Then my thumb points towards the north end of the solenoid in the same direction as the field line arrows. If I was to reverse the current, it would flow from the back and around this way. So I'd change my finger direction to point that way, and my thumb would be pointing to the right, and that end would be north.